I'm going to go over some problems from the Math 3 Unit 5 Worksheet 3 on modified box plot and whisker plot. We're going to start with number 2. So here we're given the heights of 14 males, adult males, that are listed below. And the first thing we want to do is to rearrange these numbers from lowest to highest. Once you have them in order, then you can see your lowest, which is your min, so that's 64. You can see your highest, which is 75. You can find the middle number, which is your median. So here we have 14 numbers, so 14 is even, so we could split that between 7 and 7. So if I count 1, 2, 3, 4, 5, 6, 7 from the left, and cut that in half, I got 1, 2, 3, 4, 5, 6, 7 on the right. And so the middle is between 68 and 69, which would be 68.5. So that's our median. Then to find Q1, or your first quartile, that would be the median of the left side. And don't include the median in that calculation. So then you look at the left side, we have 1, 2, 3, 4, 5, 6, 7 numbers, and take the middle of that set, which would be the fourth number, because we have 3 to the left, 3 to the right of it. So 67 is your Q1. And then do the same thing with the right half to find Q3, which would make 70 Q3. Next we want to determine the interquartile range, or IQR, the lower boundary and the upper boundary, to determine and identify any outliers. So the IQR, the interquartile range, is defined as Q3 minus Q1. So that would be 70 minus 67, which is 3. Your lower boundary is going to be Q1 minus 1.5 times your IQR, which is 67 minus 1.5 times 3. Which is 62.5. Your upper boundary is Q3 plus 1.5 times the IQR. So in this case it would be 70 plus 1.5 times 3. Which comes out to 74.5. And then we can check if we have any outliers. So anything below the lower boundary, so anything below 62.5 is considered an outlier, but our lowest is 64, so that's not below our lower boundary. And then anything above 74.5, our upper boundary, would be considered an outlier, and we do have one of those. So in this case 75 is our only outlier. Next we're going to create a modified box and whisker plot using some of the information we've already gathered. Before you create that, you want to create some scale. So our min 64, we want to go span this from 64 to 75, and so we develop a scale for that. So I'm going to start at 60 Now go by twos. And then for your put your 5-number summary on the board here. So 64, 67, 68.5, somewhere around here, 70, 75. And for your box goes from Q1 to Q3. So this is our box. And you draw whiskers out to your min and your max as long as they're not outliers. So our min's not an outlier, so we're going to draw a whisker to that. But our max is, so our max I'm going to turn into kind of an asterisk, so that's an outlier. And so we're going to, instead of drawing to that, we're going to draw to the second largest number in our data set, which would be 73. So I'll plot 73, and there we go. So this is our min, this is Q1, our median, Q3, and our max is here. And then that second whisker goes out to the largest number that's not an outlier. So D asks, if the outlier were removed from the dataset, how would this affect the mean of the dataset? Explain your answer. Well, if we remove the 75 is our outlier, which is the largest number. If we remove the largest number from our dataset, then our mean would go down because we're getting rid of the largest number in there. So the mean would decrease because we remove the largest number in the data set. E, if the outlier were removed from the dataset, how would this affect the standard deviation of the dataset? Explain your answer. Again, the standard deviation, if you remember, is based on differences from the mean, and your maximum or your outliers are furthest from the center of your data. So the outliers contribute to a larger difference, which contributes to a larger standard deviation. So if we get rid of the outliers, our standard deviation will be smaller. So the standard deviation will decrease because the data will be less spread out. Next, I want to skip down to number 6. Number 6 says, suppose the Buck Depot, which currently sells 492 distinct items that cost between 25 cents and $1, decides to sell an item that costs $5. Select whether the value of each statistic for the prices of the items at the Buck Depot increases, decreases, or cannot be determined. Excuse me. So the mean Well, we have a bunch of items between 25 cents and $1. And then we automatically add one way to the right here at $5. So we're adding a much larger value. So that's definitely going to increase your mean. Definitely going to increase your standard deviation as well, because your data is becoming more and more spread out. The median is your middle value, and this one is hard to determine. For example, say we just had a smaller data set. Say we had 0.25 and we had some values in between. Say we had 0.5, 0.5, 0.5, 0.5, 1, and then you added $5 to the bunch. So before the $5 was added in, the median was going to be, well, I had just these pieces, so the median would be at 0.5. After I add that 5 in, well, the median moves over a little bit, but it's still 0.5, so it doesn't change. It stays the same. On the other hand, if we had different values in here, and say this was 0.51, 0.52, 0.53, 0.54, and so on, by shifting over a little bit, it would increase the median. So it's either going to be increased or doesn't change, and so we're going to write cannot be determined. But generally, outliers don't affect the median much. The mode is the most occurring value, so the value that occurs or repeats itself over and over and over again. So again, if I had 0.25, 0.5, 0.5, 1, 0.5 would be the mode because it's repeating itself more than the other values. So by just adding a new value in, it's not going to affect the mode at all. So the mode won't increase, decrease. It can be determined, so we're going to add a fourth column, which just stays the same. And so we're going to put an X for that one there. And now we've answered that question.